Hi everyone, my name is Ioannis Davis and I am a senior in the kinesiology program at Montana State University. Today, I will be covering the incline dumbbell bench press, specifically informing on how to properly joint stack. The constraints-led approach will be used as the theme for this presentation. The constraints-led approach involves manipulating the task, individual, or environment in order to help the individual achieve or perform a certain task. The constraints-led approach in this project will involve manipulating two task constraints in order to help athletes properly stack their radiocarpal and ulnohumeral joints. The target audience for this project are strength and conditioning coaches, athletes, or casual lifters. The incline dumbbell bench press relies on several motor processes that work together in order to coordinate the movement. Your hands, muscles, joints, and brains are constantly sharing information, ensuring that the bench press stays smooth, coordinated, and the joints are stacked. First, pressure in the hands are detected by cutaneous mechanoreceptors located under the skin. These mechanoreceptors are always detecting the pressure of the dumbbell on the hand. The pressure information from the cutaneous mechanoreceptors informs load balance and if the press is moving up in a straight line. The second is proprioception. Muscle spindles and Golgi tendon organs located in pectoralis major and the triceps group, as well as around the glenohumeral joint and ulnohumeral joint, give us real-time feedback about joint position and muscle stretch and length. The third is vision. As you look up at the dumbbells during the pressing movement, visual input helps inform bilateral symmetry and timing of the movement. This information also supplements proprioceptive information coming from the joints and muscles. Together, these sensory inputs support the movement. Pressure in the palms help with load balance and the vertical component of the press. Proprioception gives detailed information about joint angle, muscle length, muscle stretch, as well as symmetry. And lastly, vision confirms that both dumbbells are moving evenly through the full range of motion. 3 studies were used to supplement the information for this project. The first article I used was by Gray in 2020. In this study, baseball hitters were taught opposite field hitting using different coaching styles. One group was coached using traditional prescriptive methods, which is explicit direction, and the other group used the constraints-led approach, where the coach changed practice solutions, forcing the hitters to self-organize and figure out a new way to hit. The key finding of this study was that the constraints-led approach led to a more effective swing in the batters, as well as better adaptability and transfer to in-game performance. This supports the way that I am coaching the incline dumbbell bench press. Instead of giving the athlete verbal cues, we give them a different way to perform the movement and allow for self-organization to happen. The second article by Rueda et al. In 2024 looked at how bilateral proprioception adapts with training. In the study, they compared a control group to musicians who have a lot of experience coordinating both hands in very complex ways. The musicians showed different neural activation patterns and better bilateral proprioceptive control. The key takeaway in this study is that bilateral proprioception is trainable. The sensory and neural systems that track limb position on both sides change with practice. For the incline dumbbell bench press, that means that dumbbells work this proprioceptive bilateral symmetry. It also means that the dumbbell bench press is not only for strength, but that it trains bilateral proprioception, especially when we use constraints that highlight wrist and elbow position. We are training the nervous system to coordinate both arms under load. Coaches can think of the incline dumbbell bench press with constraints as a way to upgrade bilateral proprioception and neural coordination. The third article was a systematic review performed by Winter et al. In 2022. They looked at many different proprioceptive training programs and how they affected both proprioceptive function and motor performance. Across these interventions, proprioceptive training consistently led to changes in proprioceptive function and motor performance. For the incline dumbbell press, this supports using movement-based constraints as a form of proprioceptive training. Required equipment include a band for the constraint, a small dumbbell to demonstrate the constraint, dumbbells the constraint will be performed with, and an incline bench. Now, let's run through what improper joint stacking form looks like, and then we will take a look at correct joint stacking form.
Here, we can see that the athlete is not properly stacking the joints. A marker on the styloid process of the ulna and the lateral epicondyle of the humerus illustrate this. Now here is an example of an athlete performing proper joint stacking, keeping the styloid process of the ulna over the lateral epicondyle of the humerus.
Constraints such as the offset grip of the dumbbell and the use of bands between the wrists are both examples of task constraints. These are superior to explicit direction because they allow the athlete to self-organize their own movement. Now, through repetition and self-organization, the athlete emerges a new movement pattern, in this case, joint stacking.
The first constraint that we can implement would be an offset grip on the dumbbell, while sliding from the middle of the dumbbell to the medial side of the dumbbell. This introduces instability and variability to the movement. Theory is that the offset weight will force your wrist to properly align and help stack your joints.
Another task constraint that we can implement is the use of a band. This band can be doubled up and placed between the athlete's wrists. Now, in the start position of the bench press, the athlete's wrist will be pulled together by a tension in the band. As the movement is performed, through elbow extension, the athlete overcomes this tension in the band. This reinforces the movement pattern of keeping the wrist aligned over the elbow. Please note that this movement should not be performed under high load as it is extremely unstable and variable. Now, let's take a look at proper joint stacking form using both the banded and offset dumbbell grip constraint. Here, we can see the athlete performing proper stacking of the joints using the banded constraint. Here, we can see the athlete demonstrating proper joint stacking using the offset dumbbell grip constraint. This concludes my visual project about constraints-led approach in coaching joint stacking during incline dumbbell bench press. Thank you guys for hanging out with me, and as always, go Cats.